All right, and at the end of the last video, we introduced an idea related to fundamental theorem of calculus, and actually, I'd argue we actually did part of the proof. So fundamental theorem of calculus part one, formally stated, has the condition that if f is continuous, right, a very general condition, then and also if we have a function defined as an integral, where a variable is in the bound of the integral, right, let's see, we can then differentiate it. We can differentiate g and just get f of x. And I would just clarify that technically we're still beholden to the chain rule, so we'd have to multiply by times the derivative of x, which is just 1 here. So that's why it isn't shown here. But so if we assume that if we wanted to prove this theorem using FTC part 2, I think really we did it up here, right? So we did g of x is equal to that, and then we said, okay, by evaluation theorem it's equal to that, okay, and then after that we differentiated it, substituted it in, and just simplified, right? So that would be the proof using FTC part 2. So this is done. There is another way to prove it, and I am just going to show you the non-FTC part 2 way. It's a little bit longer, and let me see if I can get the whole thing on my screen. But there you go, and I'll just say, if you want to pause the video, write it down, you're welcome to, and I will explain it briefly here in a moment. Okay, so the idea is we have to define this. So again, maybe backing up. So we know that x is some point between, or x some value between a and b, right? And so that's what this interval is showing up here. B isn't necessarily shown. B would be, off on the side here. Okay, but x is someplace between a and b, and then what we're doing is looking between x plus h. H is just a small little positive number to differentiate x plus h from x. And we're looking at the difference, right, between x and h, and then you can see we're going to eventually do a limit. And then write those out by definition, okay, and then use properties of integrals to rewrite it. Divide by by h, multiply by 1 over h, okay, either one, okay. And then we have to pull in the extreme value theorem. Okay, that's what EVT stands for. Extreme value theorem. So extreme value theorem says a function that's continuous on a closed interval attains its maximum and minimum values. So that's what this is saying. Minimum, maximum, respectively. Substitute all that stuff in. And then we're saying that there's a way to represent these minimum and maximum using the function. Okay, apply a limit, and then by the squeeze theorem we get the result that we wanted. Okay, again, that's the details more or less. I could maybe write it out more formally, but that is enough. Okay, so but big idea. Fundamental theorem of calculus, we are taking a function defined as an integral and then looking at its rate of change, which gives us back the original function. Okay. In the upcoming videos, we will take a look at some examples using FTC part 1 specifically, just because FTC part 2 has been used frequently with the evaluation theorem last week.